Weird sciencey facts that boggle my mind. I'm not Chris Angel, but this one's gonna be a mind freak. Time is relative, and gravity and speed affect how time moves. Gravity is not constant, and mass affects gravity. So all mass has gravity, and gravity bends the fabric of space. Maybe it's because I'm not Bender, but how you can bend emptiness is just, I can't wrap my head around it. But like putting a bowling ball on a mattress where it kind of like dips down, that's what gravity does to space, except in 4 dimensions, apparently. And then time, which is part of space, it's called space-time. I don't know, they just go together because they're friends or something. I'm not really sure. That changes in effect to how that gravity curve folding, bending thing is happening. So the more gravity and the more that space bends, the slower time moves. Also, the faster an object moves, the slower time moves for that object. So like, for example, astronauts on the International Space Station being less affected by the heavy gravity of Earth and moving very fast around the Earth are aging slightly slower than all of us standing here on Earth. Now this happens. This is not a philosophy. This is real. It is demonstratable. They know this happens. This is fact. All of this is based on theories from Einstein. And I really wanted to do a video trying to break this down and explain how this all works. But it turns out I am not Einstein, and I just can't wrap my head around the concepts. Like I've read the stuff, and I've done my best to try to like process it, and I can't process it. Just cannot process it. But what I can tell you is that because this is the way that the universe works, we can time travel. Kind of. We, right now today, can photograph the past. We can take pictures of things that happened billions of years ago. In fact, we can take pictures of the universe moments after the Big Bang. And we've done it. We have photographs of the beginning of the universe, some 380,000 years after the Big Bang. Which might sound like a long time, but the universe is 13.7 billion years old. So 380,000 years is a matter of seconds in relative terms. And they've done it, and you can look at it. You can Google it. It just kind of looks like the shit Predator sees to me. But to scientists, this is really cool. But what's more fascinating to me than the picture itself is how. How do you get a picture of something that happened before the Earth, before the sun, before any stars or galaxies ever existed? How do you get that picture today? And the answer comes down to light and the speed it moves at. The speed of light. Light moving at the speed of light is important for 2 reasons in our ability to look back in time. And the first is that light doesn't age. Light particles traveling at the speed of light through the vacuum of space does not experience time nor distance. So while those photons, those light particles leaving the sun take 8 minutes and 20 seconds of my time to get here and hit my skin, for them, they were here instantly. Not a single millisecond has passed. What's more is they have also traveled no distance. Figure that one out. I can't. This means that light doesn't change. It doesn't decay over time. So no matter how long ago light was emitted, when we see it today, it's exactly as it was when it was created. Just remember, because no time has passed from the perspective of the particles of light beaming through space from the beginning of the universe, from our perspective, the further something is away from us that's emitting light, the longer it takes for that light to reach us. We can measure that time. It's called light years. Put it in a more relatable perspective. Imagine we built an interstellar spaceship that could travel nearly the speed of light. And you take that spaceship to a planet that is 100 light years away. How are you going to do that? You can't live for 100 years. And you don't have to, because you will arrive at that planet 100 light years away almost instantaneously. But in that instant, Earth has aged 100 years and everybody you knew is dead. That's how time is relative. In the same case, a lot of the stars that we see up in the night sky that you're wishing on, like your dreams, are already dead. I'm just kidding. I have faith you can achieve your dreams. But that is exactly how we got the picture of the beginning of the universe. Those long dead stars that still shine bright in our night sky that you're looking at those from back in time. They don't exist anymore. We're just waiting for the rest of their light to get here. And because the universe is constantly expanding, and it's expanding away faster than the speed of light, we've gotten so far away from that center point of the Big Bang that we can now take pictures of areas just around when the Big Bang happened, because there's still light from that event that are just now getting to us. And because that light hasn't aged, we're seeing these images from the early moments of the universe exactly how they were. And the fact that as scientists are able to build more complex and technologically advanced telescopes and space probes, they are building time machines that let us see clearer and clearer pictures of the literal past. And these time-traveling pictures are actually helping us answer the mysteries of the universe. Well, that is pretty mind-boggling.